So if you're starting to work on Azure Databricks, there are high chances that you're going to hear the term a lot, Azure Databricks Workspace. So what is that? It's the top level environment for accessing any and all of your Databricks assets. What are these assets? On the right hand side, you can see those assets like clusters, pools, notebook, jobs, library, repos, to name a few. These are not all. There are a bunch of other assets as well, but these are the primary and the major ones which you're going to use day in day out. So it's the logical separation. It's the separation to keep your environments, clients, notebook and data repos segregated from any of your environments or clients. Let's suppose you have a client and you want to make sure that all of the environments, production, dev and non-product sandbox, are segregated from each other. You could just create different workspaces, and underneath the workspaces you'll have different assets for pertaining to different environments. Now let's suppose if you're coming from Azure background, you would be able to relate it pretty well. So subscription is the top level hierarchy, and then underneath the subscription you've got your resource group, and underneath each resource group you have your resources. So subscription is the top level umbrella in Azure, and underneath that you could have multiple resource group. Like for team A you would have one subscription, for team B, for engineering team you would have another subscription, for data team you would have another subscription, and underneath the data subscription you would only have data resources. Similar to that, workspaces you would could just have it for different clients or different team as well. So it's basically to isolate your environments. Now let's get into our Azure portal, wherein we're going to create our first workspace and see what all components it can have. So I'm going to create on new Azure Databricks service. So it's going to ask me with subscription standard details I need to pass on. Databricks Workspace. Yep, and the name is Code Red Workspace. All right, then the region, and then the pricing tier. You could have standard, premium and trial. Only difference between standard and premium is everything is covered in premium, just that with premium you get role based access control from Azure as well. um, if you move on to the next one, you've got your networking, which we're going to leave for now. You could just restrict that deploy Azure Databricks with secure cluster connectivity, which means it wouldn't have any public IP address, and you could just attach your own virtual network as well. Then you've got the advanced setting, then you've got the tags and review plus create, and once it is validated you could just hit on create, and that's gonna start creating your resources. All right, so this is going to create the Azure workspace, and it's going to take a few minutes to create. All right, our resources is now created. Let's go to the workspace. Now that's the UI when you first hit onto the Azure Databricks. On the left hand side you get the standard information. One thing you would notice that you get something called as virtual network peering as well, which helps you to connect another network. And let's suppose there are two companies, A and company B, both have just collaborated with each other and they would like to access each other's service. In those scenario, you could just peer your network, which means you can integrate two virtual network, and the workspaces attached to that particular virtual network could just communicate with each other seamlessly as well. So you could just have it within the subscription, or the network which belongs outside your current subscription can be attached as well. Let's go to the UI. The first thing you would notice that the manage resource group. This is, if you click on this particular resource group, you will see that there are three resources. One is the virtual network, which is attached with your workspace, and then you've got the security group where you define all the security groups, who should access, which IP address should have access, and then the storage account to keep your OS or the system information, the underlying code wherein the workspace is running. Now, if you go back to our original workspace, so that this particular managed resource group would be deleted or would be created along with your workspace. So if your workspace is created, this particular resources would be created as well. And if your workspace is deleted, you would have this managed resource group also deleted. All right, so if you just now launch the workspace either from this URL or from here, the first thing you would notice that it comes with the single sign-on. You don't have to log in because that's the benefit of using the Azure Databricks. You get the seamless single sign-on authentication, and you get backed by Azure Active Directory, which is the native service, is one of the oldest service from Azure. Everybody knows about Active Directory, and with Databricks you get the authentication for Azure with Azure Databricks as well, leveraging the Azure's data and Active Directory together. So first thing is that's your workspace name, and ADB is Azure Databricks, and then this is your workspace ID, and followed by the static, which is across uniform across for any of your Azure Databricks subscription or the workspace URL, and then at the end you would have the same as your workspace ID. This is especially handy when you needed to connect certain tools or call certain APIs. Then in those scenarios you would need the workspace ID. So that's the workspace ID, and on the left hand side you would see multiple options. We're going to go one by one, like workspaces, data, clusters, jobs, models, and on the UI you would see bunch of shortcuts, and you could explore or import data files as well, which you would like to perform computation or run your data engineering or data science or analytics workload on top of those data. All right, the first thing first, let's create a cluster first, because that's where your notebooks would be attached with, and all of your queries, all of your data computation, all of the analytics going to be running on top of those clusters. Clusters are nothing but underlying virtual machine, which is managed by Azure. Again, however, you take care of the provisioning of these clusters. These are set of computation resources and configuration wherein you could just run any of your data analytics or engineering or science workloads. Maybe it's ETL pipeline, streaming analytics coming from Kafka or Event Hub, maybe any of the ad hoc analysis you want to run, or you want to run certain CSV and churn out meaningful information out of those, or you want to train your machine learning models. Any of these could be. So once you create the cluster, now this cluster is again used for computation, and anything you type in your workload or your notebook rather, it would be running on some sort of machine, right? And this is your machine, that's called your cluster. I'm going to give the cluster name as code red cluster, and there are three types of cluster you would see: managed, um, standard, higher concurrencies, and the single node cluster. There are certain differences between three of them. Single node cluster is beneficial for only handling wherein you haven't got any worker or driver node. Everything runs on single node cluster, and it's beneficial for a single users. Then you've got the high concurrency, which is a managed clouds resource, which is one of the resources which is specifically needed to run where you need more computation powered and minimal query latency. In those scenarios you could just use high concurrency cluster. One of the downside for that is it's only available for SQL, Python, and R languages. For Scala it's still not running, so you'll have to use either standard or single. So we're going to go ahead with the standard one for the sake of the demo. If you look at the pool, don't worry about it. We're going to come back what pool is all about. For now, we're going to just select none. We'd rather don't even need to select one. Now we're going to come back to our Databricks runtimes. What is a runtime? So if you click over more, you would see that there are more options coming up. So Databricks runtime comes with the open Apache Spark APIs with highly optimized engine. What does that mean? So it'll come up with all the predefined softwares or APIs which you need to run your data engineering analytics or data science, or you want to do any of your data churning in and out. So you could do that. Whether you want to run your machine learning model, whether you want to do any of your Spark code, Scala code, or Java, Python, or R. So it's basically a runtime which is comes with predefined installation of your Java, Scala, Python, R libraries. It also comes with Ubuntu and its underlying system libraries. It also has a lot of graphical GPU based runtime, which is specifically needed for your graphical processing unit. For just like in case of coming from NVIDIA or other GPU enabled. So if you need higher runtime cluster, you could use them also to process any of your machine learning models, or using more of a highly computation powered using the GPU based runtime. For now, I'm going to use the latest one. Comes with the Spark 3.1 and the Scala 2.12. Um, and then you've got the auto scaling, enable auto scaling, and then it comes with the auto termination as well. These are pretty important feature. Auto termination is a feature which kind of helps you whenever your uh, cluster is inactive for a certain amount of time. Let's suppose your cluster is inactive for 10 or 15 minutes. Nobody is performing any of the task in the cluster. Your cluster would be terminated automatically. That is specifically helpful if you want to save some of the cost wherein your clusters are not utilizing. Um, and then you could probably set a termination time. Okay, if the termination is if the cluster is not used for 20 minutes, just terminate the cluster, which means it's going to shut down the machine and you won't be charged anything for those beyond 20 minutes. Enable auto scaling if you want to make sure that if you're running some sort of data engineering analytics in the backend, and you want to make sure that your cluster could automatically handle the load, increase the load automatically for you, you want to use the enable auto scaling features, and that is specifically useful when you don't want to just resize the clusters manually. Rather, you want to make sure that your cost and performance perspective also, your auto scaling kind of handles the clusters increasing size and the cluster decreasing size on its own. That's specifically useful. Now the worker and driver. So obviously Spark works on a master and slave model where you got your driver which instruct worker to perform, run certain analytics. So worker node is the one which you would select the machine type, whether you want a higher machine type or the minimal one. For now, I'm going to just select a basic one, and then I'm going to select a driver type as well, preferably same as worker. You see something called as spot instance as well. What does that mean? Spot instance is something from Azure, wherein you could just um, use Azure's unused machine. And those, why do you want to use them? You use them because they are really cheap. Because Azure allows you to take advantage of their unused capacity at a significant cost saving model. But the downside is whenever Azure needs those machines, they would just take away those machine and you would switch back to your general available machine. So spot virtual machine are great for workload that can handle interruption, like your batch processing jobs or any of your dev or test environment. Obviously Azure doesn't recommend you to use spot instances for your production workload, but in case you're working for dev, and where you can handle such interruption, you could just use spot instances where you could just save a lot of pennies for your company. So that's the story behind the spot instance. You could just enable it. I'm gonna make the maximum as 2 as well. And then I've got the advanced option wherein I could just use what are the options apart from the one I've already selected. You could just come up with your Spark configuration where you can just give the configuration, the basic configuration like spark.databricks.io, wherein you want to enable the caching enabled, and you want to make sure that the caching is enabled. So you could just use the Spark configs, and then you've got the environment variables. You've got the tags as well. By default, you've got a bunch of tags like the vendor, creator, cluster name, and the cluster ID. I would highly recommend to use these tags if you want to segregate certain clusters for certain teams. Like at the end of the month, you want to make sure that which team utilize the maximum amount of clusters, not because you want to penalize them, but you want to understand their usage, and so that you can plan your capacity better. So you could just give a team as data engineering and just add this tag, and then you could just enable the logging as well, with a distributed file system path. Want to make sure that every logs coming out from the cluster should go into this particular path. I'm going to enable so that we can see it later. Then got the init script, initialization script, wherein you want to make sure that certain scripts or certain softwares are installed when the cluster starts or reboots. So that's where you want to use the init script. We're going to skip this init script for now, but we're going to use it, the global init script, which I'm going to cover in a separate section. All right, our cluster kind of looks fine. I am going to hit the cluster create, and now it's going to start creating the cluster. Majority of the UI is now not available because the cluster is still trying to create. But if you go to the event log, you see that the cluster is now starting to create, and it was operation given by myself. And you could just bifurcate all of the event spaces on certain status, and then you've got the driver logs, which is still kind of not available at the moment, and metrics. And so let's give it a few minutes and this should be starting up. Alright, so our cluster is now created. You would see a bunch of information like the state of the cluster, whether it's running or terminated. Then you've got the number of nodes underneath that cluster, the runtime environment, which all APIs or which all libraries it has come up with, and then driver and the standard type version, and then who created it, and then bunch of other information. If you notice over here, there's a pin button right over here. Pin option is specifically needed if your cluster is terminated for 30 days. uh, it gets permanently deleted after 30 days. If you want to make sure that it's not deleted even after 30 days, you want to just pin the cluster. Now this highlighted pin button shows that even after 30 days the cluster won't be deleted. You could just pin up to 40 clusters at the moment. And now if I just click on the cluster, you will see all the information. We don't have any notebooks running at the moment, libraries. Then the event logs shows the events which happened within the cluster, whether somebody automatically started the cluster, or somebody or it was healthy, the cluster is healthy or not, or the cluster was pinned by me. So that all those information comes up right over here, right over here. Then you've got the driver logs. Now driver logs shows certain information around the three different logs: the standard output, standard error, and the logs. So you could just stream these logs to certain to some as a files as well, and then you could visualize them later as well. And then you could go to the metrics. Now metrics shows you some of the monitoring capability of Databricks. You could just use the Ganglia, which is one of the tool to help you with monitoring for any of the distributed system, wherein you can see that what was the cluster load time for last couple of hours, what was the memory, and then what was the CPU, network, and how much load, or what were the set of event which happened on top of the cluster. Obviously, you got to set this up and get the best out of it. Um, I don't find this tool specifically very UI friendly, so either you could use this, or it also helps you to there's other tools like Datadog. Also, you can install Datadog as an inet script, which I'm going to show you in the inet script section, wherein you can send all of your metrics to Datadog as well. Then you've got the apps. You could just enable the web terminal as well. How do you do that? At the moment, it's you could basically uh, log into your driver node. It's disabled at the moment. However, if you go to the admin console, and if you go to the access control list, you would see certain information available over here, and you could just enable or disable the all the um, uh, repos, or your driver access as well right from here. If you go back to the cluster, um, and you've got your apps, and then you've got the master Spark UI, which tells you what all jobs are running at the moment. At the moment, obviously, we don't have running anything. So when you're going to run something on your notebook, some Spark application, or Scala or Python application, you would see them executors executing those jobs right over here. So that was about the cluster. Now let's probably try to understand what are pools and what's the relation between your pool and a cluster. So when we created a cluster, we noticed that it took some time to reboot itself, and if there are certain worker nodes which are not available, it's gonna spin them up on its own. There is a significant relation between pools and cluster. Pools reduces, specifically it helps you in reducing cluster start and auto scaling time by maintaining set of machines, set of ready to use instances, and whenever your cluster is attached to any pools. If you notice, whenever we were trying to create our new cluster, it had asked for whether you want to attach it to any pool, and we had selected none because we didn't have any pool attached. So if pool has multiple machines and cluster is attached to one pool, it could just ask, okay, pool 1, can you lend me some instances so that I can attach it to certain notebook, and so that the data engineer can run the data transformation on top of that particular notebook. And what pool is going to give you, uh, tell the cluster is, okay, I have bunch of machines available, you could just take one, and whenever the cluster is done with all its data pipeline, or whatever process the data engineers, the scientists wanted to run, the cluster is going to terminate and give the machine or instance back to the pool. So it helps you drastically to save time when a notebook or a process quickly wants to save time when it comes to starting or auto scaling the cluster. Pools actually helps us. Also, you can just segregate pools basis on certain teams, or let's suppose data engineering team, data scientist team, data analytics, all of their pools can be segregated because many teams can have many different pool needs, and you could just understand their needs by segregating, or cater to their needs by segregating different pools. Now let's go back to our cluster again. If you go over here, you will go to the pool, and you could just start creating pool as well. Now the pool could be all cluster pool, and then you could just say how many minimal idle instances you want to keep. These instances do not terminate regardless of whatever settings or configuration you provide. If a cluster kind of consumes all of the ideal instances as well, Databricks pool gonna make sure that it maintains additional minimal idle instances. You want to make sure that every time it has one idle instance available, and the maximum capacities it can go up to whatever the quota support you have. Remember, one thing I've generally faced while creating clusters, your Region might have some quota limitation. So if you're getting some errors like you had 350 instances quota available, you've utilized more than that, what you just need to do is probably reach out to your Azure support team and then just tell them to increase the quota up to certain limits, and that's basically going to be really, really quick. So I'm gonna give the capacity as 10, and then the idle auto termination, which is again the same. The time in minutes that insists above certain value can be idle before terminated by the pool. And then you could just select the instance type, and then the runtime as well. You could just select whether you want all of the on-demand or all spot instances. You know what's the difference between them. We discussed about in the last while creating our cluster. Now, if you could just create the cluster, it's gonna tell you that okay, there are minimal one idle instances, and then used is 0, idle is 0, and maximum capacity is 10. Now, if you go to the cluster, um, and you could just start creating cluster with a pool cluster name, pool cluster standard mode, and then the pool name would have the all cluster pool. And then if you notice, you can't change the cluster worker type now because it's already been predefined in your pool. That's why you can't change it. Now you can just create it. Either you could just get series of events, or it can get terminated because of the quota limitation error. You would notice something called as job clusters as well. Job clusters, we would notice whenever we run job, then only these clusters are created, because you would have two types of clusters, like the all-purpose cluster, which is basically is used by your data engineers for general purpose to churn out data, to read data, or to transform data. However, the jobs are when you want to run a job, automated job, non-interactive session, then in those cases Databricks would automatically spin up the job cluster so that you have a dedicated cluster to run your jobs uninterrupted. Nobody is using it. When the job is run, the job cluster is going to be terminated and deleted. All right. So that was about from the Databricks fundamentals. This is how you could just maintain all of your workspaces and the assets underneath your workspaces with GUI. We're going to learn how you could do them using CLI and Terraform as well. I hope this was informative. Thank you.